Well, could you please introduce yourself to us?
Okay, so my name is Gitta Neufang. I'm working in the R&D department of Bayersdorf in Hamburg. And so we are interested in analyzing what are the skin needs of inflamed skin, of severely affected skin, and our special interest was also to see which diseases, which are normally not really skin diseases, also are affected by a skin phenotype. And so that's why we looked, or a PhD student of mine looked into what are the differences between the skin of diabetic type 2, diabetic mellitus type 2 patients versus healthy control groups. And so we did a comprehensive analysis of this, and we found really interesting changes in skin or also in skin cells derived from diabetes patients compared to control groups.
Can you walk us through some of those changes you found?
Yes, of course. So one major change we saw, or what was most surprising, that there is something like a diabetic signature of keratinocytes we derived from diabetes patients. So they were not able to respond properly to insulin. So we saw a reduction in the insulin receptor response and transcription, and this led also to a impaired uptake of glucose in diabetic cells. So diabetic keratinocytes were not able to take up glucose properly because also the transporter system was affected. And then we looked a little bit into more detail into this phenomenon and did three-dimensional skin grafts, so of diabetic keratinocytes and diabetic fibroblasts, and then we analyzed the inflammatory status. And also here we could see that you have something like a pro-inflammatory phenotype in diabetes organotypic cell cultures, so in 3D models of the skin. So cytokines like IP10, EL8 or interleukin 1 beta were increased on a transcription level and also on a protein level. So this was really, really interesting. And in combination with this, also the antioxidant defense system of the skin cells were impaired. So they were not able to cope with oxidative stress as like control cells were able to do so. So one very central transcription factor, NF2, was reduced, and consequently also the protein dependent on it, hemoxygenase 2, was reduced. And so also here we see an impairment of diabetic keratinocyte. And then we got one step further. We did a three-dimensional skin models of healthy keratinocytes and healthy fibroblasts, and we innovated them, so with neurons, and compared this to diabetic keratinocytes and diabetic fibroblasts, and also innovated these models. And what we could see was a hypo-innovation, which is also the phenotype in diabetes in general. So you see less neuronal fibers invading the epidermis in diabetic skin compared to healthy, and this was due to a reduced expression of NGF, so neurotrophic growth factor. So this was really interesting for us. So we have a multiple effect in diabetic skin cells, so inflammatory, less antioxidant defense, and this reduction of neuronal growth. So this sums up to a really persistent diabetic phenotype, and now we want to look in further studies how we can compensate and what are the mechanisms behind.
Wonderful. Thank you very much.
You're welcome. Thank you for your interest.